Hello guys, I am Sumit Kumar Das and welcome back to SK Neuron. Today we are diving into something super exciting, how to interact with different types of large language models in LangChain. You are watching the next episode in our LangChain course playlist. In the last video, we walked through the LangChain setup, getting everything ready to start building. If you had missed it, I recommend checking it out to get the full context before diving into today's topic.
So first let's talk about large language models. These are the text completion models that take a string as input and return a string as output. And this foundational model trained on massive amount of unlabeled text data. Unlabeled text data. And this data can be from books, from websites, from research papers, and combinedly how they get trained upon using one method called as on supervised learning. Using this method, these foundational models are getting trained and they get trained upon for certain goal. For example, to learn language patterns, to learn grammar, or to learn the context without being explicitly taught how to perform the specific task. Okay, and these large language models are of two types. These large language models are of two types. One is open source model and second one is closed source models. Open source models are freely available to public. Okay, so these are freely available and you can access their code, you can modify it, and there are various popular platform that provides these open source models. For example, one of the popular platform is Hugging Face. One of the popular platform is Hugging Face. So these models are great for the practice and experimentation purpose because they are free and easily accessible. So how to use these open source models? So this open source model can be accessible in two ways. What? One is API based. One is API based and second one is what is download based. In this download based method, you download the model to your local machine. You download the model to your local machine and run it. For example, we take an example of DeepSeek R1. It became very famous last year. A China-based models, DeepSeek R1, which has almost 685 billions of parameters. How much? 685s, whose size will be almost 600 to 700 GB. So for these big size of models to use, you need very high computational GPUs. GPUs are itself are high computational resources, but still it's the model size. If you see, this is the full size model. Okay, this is a full size model. To use this also you need very high computational power. But I just told you 685 billion parameters. But what are these parameters? Let's understand that first. So these 685 billion parameters are called as model parameters. What they call as model parameter. Sometimes also they call as training parameters as well. So these are the parameters, or you can understand like these are the variables that the model learns during the training process. I mean, when you are building that model from scratch. Few of the common types of parameter are there. One is called as weights and second is called as biases. So weights and biases are one of the most common type of training parameter used to train these large language models. What are weights? Weights are the coefficients. So these are mostly coefficients that are multiplied by the input features to make predictions. So input feature get multiplied by these coefficients. These are called as weights. It means to each of the input, what are the inputs here? Inputs are text because we are building large language models. The models based on the language. Language means text. So for each text, or we can say like each token, that is the smallest possible unit which will be getting trained on the model. For each token, we are assigning certain importance to it. That important of that token is called as weight. And how we are determining it? By multiplying with a coefficient number. And then we have biases. These biases, what we can also call as offsets. What does it mean? It allows the model to make prediction even when all the input features are zero. So let example all the inputs are zero. Still it will give some value or some prediction it will do. Based on what? These offsets. Okay. Then this is the one type of parameter, what I say as model parameter, which is we just discussed the 685 billion number of parameters are there. Then there is one more type of parameters are also available. What are hyperparameter? This hyperparameter, these are not like the model parameter. They do not get learned from data. These values configure before the training of the model. They configure before the training of model. And they will be same throughout the training process. Once they configure means they will be keep same. They will not change throughout the training process. For example, one of the example here is learning rate. What is this learning rate? This learning rate, it controls how much model weight are adjusted during the training. Meaning, what does it mean? When your learning rate is high, it means you are doing speed training. Means you are doing speed training. But it sometimes lead to suboptimal solution. If you will train the model in high speed, it will sometimes can lead to suboptimal solutions. When the learning rate is low, it means it gives to slow training, and it generally leads to more precise solutions. It generally leads to more precise solutions. And these learning rates typically range from zero point 0.1 to 0.001. Then there is one more parameter called as batch size. Batch size means the number of training samples used in one iteration of the training process. When you are training for one iteration, means for one cycle, you are training the model. In one cycle, how many models you will be used? In one cycle, how many training sample you will take to train the model? So this is the what? Number of training samples. Okay. Used in one iteration. So the larger the batch size, more the training, faster the training will happen, right? Because more number of, suppose you have 100 number of training inputs, let's assume, and in one cycle I am training 50. It's just a random example I'm giving. There will be more number of data size in real life. Then, so in two sets of iteration, you can take 50 and 50. So your training speed will be much faster. But if you are taking 10, then you need to iterate it for 10 number of cycles. Okay. But when you are taking more number of samples, it need more memory. So when batch size is high, you need more memory. Means if you have trained 50 text data, 50 tokens, you need more memory to uh, train those model. But when you have less batch size, you can train it on less memory based CPUs or GPUs. So what are the general batch size? A typical batch size like 32, 64, 128. So these are generally in the 2 to the power n range of sequence we mostly take while you do the training of the models. Okay, then there is one more parameter called as epochs. Epochs means the number of times the entire training data set is passed through the model. Okay, it is basically nothing called as number of cycles or the number of times entire trained data set is passed through the model. And in each epoch, the model tries to reduce the error that occurred in the previous epoch. So more epoch obviously always lead to better result because more error you are trying to reduce. Okay, but sometimes when you have more epoch, it leads to overfitting. More epoch obviously lead to better result, but it sometimes can lead to overfitting as well. Okay, and these epochs generally like 10 to 100 kind of range. It depends upon how many. I mean, this is a typical range, but it again depends upon what is the batch size you are taking, what is the learning rate you are. So combinedly, these all are being uh, keep in an optimal numbers so that your output become. Then there is one more parameters, one more type of parameter, what we call as inferencing parameter. What we call this as inferencing parameter. So once your training is completed and you start using the model to make predictions or generate outputs, then you use this kind of parameters. And it helps to control the behavior of the model during the inferencing phase. Means while you are using that model, not training. Training is done now. Now you are using that model. I am using GPT model or chat GPT to get the output, asking question and getting the output. In these situations, what are the parameters you are using that are called inferencing parameters? So used while predicting, while predictions. So what are the examples here? For example, temperature. What is temperature? Temperature controls the randomness of the model output. What does it mean? Suppose you have high temperature. For example, 1. If you value have 1, it is high temperature. It means your output will be more creative and more variable. I mean, every time you enter the same question to the model, it will give you different response with new creativity. But when you have low temperature value, for example 0, then you have more deterministic kind of output. Every time you give the question to the model, it will give you the similar kind of or same kind of output. So it determines the randomness of the model's output. Then there is one more parameter called as max token. Max tokens. This limits the total number of tokens that will be used while generating the model response. It always ensures that output does not exceed a certain length. Means this is the limit of model response. Suppose I give max token as, for example, 512. So the model maximum will give 512 tokens in the response. It can give less than that. From 0 to 512, it can give the output. But greater than 512 tokens, it cannot print it. There are many other parameters like this. Okay, there is one more parameter called as top P and top K. These are the two parameters interchangeably used. Top P, that also controls the randomness of model output, but it considering a threshold of probability. I mean, for example, I give P as 0.9. Okay, then it considers the smallest set of tokens whose cumulative probability either goes greater than or equal to 90%. It helps the model to dynamically choose from a variable number of tokens based on their probabilities. While top k is an alternative to top p. Here, model considers only top k tokens with highest probabilities and samples from them. So, for example, I give top k as 50. So, it will consider the top 50 tokens having highest probabilities. And from those 50 tokens only, it will give you the result. So, top p is the cumulative probability. It considers cumulative sum of probabilities greater than or equals to zero point 0.9. Here, top 50 tokens are highest probability. Okay. So the most used parameter while using a model is the inferencing parameter. And these are the most parameters we will be using. Open source models is having 685 billion parameters, whose full size having all the model parameters, training parameter completely will become around 600 to 700 GB. And this is nearly impossible to even download and run them on any system unless it has very high super powerful company system. That's why model providers generally what they do, they release quantized version. What they released? Quantized version. Quantized means small compact version. What exactly quantization is, we can cover in another video. For now, we can think like quantized means small compact version of the same 700 GB or 695 parameters. It will perform almost near to that, but obviously not exactly to that, but parameter performance will be almost at par to that. 1.58 bits quantization will happen on this. So model size will be reduced from 700 GB to almost 100 GB. See, almost 1/7 we are doing the size by using this quantization process. Okay, so this is one way. This is one way how to use open source models. The another way to use is API tokens. This API token methods involves getting the API token. For example, the popular platform like Hugging Face. From there, you will get the token and use that token to access the models via APIs. I mean, the models is now in some server with the providers. They deploy it on some server and they created APIs for that, and they are giving you that API. But it is open source. As it is open source, so it is free to use. So the next one is closed source models. So closed source models, on the other hand, these are the proprietary models. For example, OpenAI models or Google Gemini models. Or there is another famous one, Anthropic models, right? Anthropic models. So these models are the proprietary models, and these are more often preferred by the industry because they comes with support, reliability, and performance guarantee. But they mostly require a subscription or a payment to use it. It depends on the provider. They build very good, powerful model. They don't want to give it for free for you. They want to charge for it. But many of the times, if you goes to like clouds, for example, Azure. So Azure has been linked with OpenAI. So now Azure is taking the all the securities interlinked to the OpenAI. But these are better performance model. Similarly, you have in AWS, you have Bedrock. In Google GCP, you have Vertex AI. So they all will host these models. Either you can directly use from the OpenAI server, or you can go through and access them from the cloud server as well. Bedrock has Anthropic, right? Bedrock had own Nova model, Amazon Nova model. Bedrock has Core A models, Llama models. Okay. Here, no need of hardware, quick setup, and you can use anywhere you want. Again, these are also API based. These are completely API based. So here there is no download option. Okay. So these are the kind of large language models available in the market. But when it comes to LangChain, LangChain implements all these models, both open source and closed source models, but they implement in two types of ways. So LangChain specifically implements LLM in two types of ways. One is what we call as base LLM, and another one is what is called as chart LLM. Okay, so these base LLMs are mostly these are text completion model. These are the text completion or foundational models like string in, string out. So the next one is chart based LLM. These are the advanced instruction tuned LLM. What are these? Instruction tuned large language models that undergone additional fine tuning using datasets composed of instructional prompt and expected output. It means like how human do a conversations. So it makes LLM better at understanding their human following conversation. Text completion what happen? It's like it is completing your sentence, but here it is answering your question. Okay, so the core difference between base LLM and chart LLM is this is completing your sentence. You gave a sentence, it will try to complete that. For example, I am playing. What? It will write football. It's just a very basic example. Text comprehension models are also now get very advanced, but their core functionality is to complete the prompt given by user. Okay, but here it will try to answer the prompt. Now let's see through code what are the difference between base LLM and chat LLM. First, let me import these both base LLM and base chat model. Let me run it. Yeah, now it has run. So now to see where this base LLM has been defined, you have to press Control and click it. If I press Control key, you can see inside my environment, whatever the virtual environment I have created, what are there under the requirement.txt has been installed. So inside there is a library called as LangChain Co. Inside that, I have llm.py in which I have a base LLM class. So this is where the it is just to I just trying to show you how this has been defined and where this has been defined. It's okay if you are not getting it. It is not being much useful while running the code. It's just to make you understand. Okay, now again if you come and click on the base chart model in similar fashion, you can see here the base chart model has been inserted. This is the base class for chat models. Okay, again both have been derived as the inherited class from the base language model. This also has been derived, and this also has been derived. Okay, let me import for example from langchain underscore OpenAI import. So if you see, I can import two things. One is, sorry, I can import OpenAI, then I can import OpenAI chart. So this OpenAI, if you see, this OpenAI is the base class of base OpenAI, and this base OpenAI is the base class of base LLM. This base LLM which we have seen here. While this OpenAI chart, let me run it. Mistake. It is chart OpenAI. Sorry. Yeah. So if you see this chart OpenAI, which is the derived class of base chart OpenAI, we have we have seen here it is the base chart model, right? And this base chart OpenAI is derived from the base chart model. So whatever the LLM or whatever the models are suffixed prefixed with chart are the chart based model, while all the LLMs which are either suffixed with LLM, it can be sometimes written as, it's not there for OpenAI, but it can be for some LLM, for example like OpenAI LLM, right? Or you can have, for example, Ollama LLM. So like this, let's discuss how to pass LLM keys or token. Okay, so in my previous video I have shown you how to create OpenAI tokens, Hugging Face token and Google Gemini token. Now we will see how to pass those LLM keys or tokens to the LangChain, to use those in LangChain. So there are basically two methods how to access LLM keys or token. First is using an environment file. So for that, let me create a new file called as .env. Okay, so I have created a environmental file. So here let me define, for example, OpenAI key, and here actually you have to paste your actual OpenAI key. I am not pasting it here just for the security purposes. Similarly, let me put Anthropic API key. Okay, so here also you have to put Anthropic API key. So now how, this is the first way you can define in an environment file. Once you have defined them in an environment file, how to access them? So here you can access these API keys present in the environment file using library called as .env. So let me, okay, once you have imported it, then you have to load this, load.env. Okay, once you have make the load, so here I am loading all the environment. So what I am doing here, I am loading all environmental variables. Okay, now OpenAI key is equals to, I need to import OS before that, dot get env. So you have to exactly keep what exact key you need. Okay, see, so now whatever we have defined in the environment file, that is coming up here, but let me change that variable to some other values. Okay, let me change that value to some other values. I have changed it. Let me reload it again, but now the value is not getting changed. Why? Because once I load the environmental variables, it means in my environment it is getting all loaded. So if you want to change that, you have to restart the kernel. Until unless you are not restarting it, it will not get load again. So now I restarted it. Let me load again. See, the new values is coming up. Similarly, I can also import my Anthropic key as well. Right? Let me import that. Let me, now Anthropic key is there. Okay, so this is the first way to access the API keys or tokens via environment file. Why we're using this, we can directly assign here. See, I can directly assign the OpenAI key here by defining a variable, but this is used so that I am not storing any sensitive information like API keys. These are very sensitive information without exposing them in code. See, I can store them all in the this code, in this notebook directly by assigning with some variables. But I'm not doing that because it's a security risk. I'm not exposing my sensitive information in the code, so that when I will be pushing this code to GitHub, because in production when you'll be working, you have to push your code to GitHub for CI/CD pipeline or any Git repositories, right, to store your code. So there you should not never pushed your environment files which contains all the sensitive information. So this is one way you can access. But if you don't at all want to store this environment, this security key or this API key or token anywhere in the in your code base, not even in environment file, I will say when I will run the code, I will pass it dynamically. In the runtime only, I will pass it. So for that, there is also one more method called as getpass method. That getpass method is securely allow the user to enter the sensitive information. For example, here is token or you have passwords at runtime. So for that you need one more library called as getpass. Okay, now for example, let me take my Gemini key because I have not stored my Gemini key in the environment file. Gemini API key. Okay, if I run here, you can see in the top of my screen, I am getting a pop-up where I can enter my skin. So here, let me put some values. So we saw the two ways. One is through environment file, which stores keys or token in a .env file and loads them into your code using the library .env. It is very secure and convenient way for managing multiple environment variables. But if you don't want to store your keys or token at all anywhere in the code base, then this get pass method is which will help you to pass the keys or token at runtime. Let me get a new file. Now we will see how to interact with different types of LLM models. First we will see with respect to OpenAI, then we will see with respect to Gemini, and finally we'll end up with Hugging Face. So first of all, you have to load your environment file. Then you need OS or you can take get. I am putting here both ways. Okay, so that if somehow you missed to store in the environment file, you will get a second option to put allow to enter the API key token in the dynamic way. Okay, next let me import both LangChain OpenAI. I will import both OpenAI and Chat OpenAI. Sorry, Chat OpenAI. Then I will load my all environmental variables. Okay, so now what I am doing here, I am first loading the Open API key from my environment files. Then I am assigning that to my environment so that it will be stored in my env environment. Else, if suppose I am forget to store that in environment file, then I am allowing that to enter that from the get pass method. Okay. And here one more thing is required is you need to add one more, that is API base, because some system it may gives the issue like not able to connect to API key. It may gives connection issue. So then you can add this part. Okay. So this will help you to connect to the correct URL. Okay. Now I have load my OpenAI key. Now let's see how to call OpenAI LLM as well as chat OpenAI. First, we will use to call OpenAI LLM. So for that, I need to call OpenAI function. Okay. So here by default, you can give your model name. Okay. So here by default, you can give any model name. For example, GPT 3.5. Let me give GPT 3.5 turbo instructors. I'm just giving a old model. Okay. Then I'm running it. Now you can use invoke function to pass whatever the question you are. Just passing hello, how are you? Let's see. See, it is just you gave the response, you gave the question, it is giving the response. So let me create a proper. Let me create a good question. Okay, this is a good question. You can also think like what's the answer of it. You have 3 liter of jug and 5 liter jug, and how exactly you can measure 4 liter of water. Okay, let me pass that question here. Let me print it. Now see, I had just asked the question, it is just giving the response. Obviously, the response is correct. The response will be correct because GPT 3.5 model is also very advanced model. But let me call now the chart model. Then we can see the exact difference between both of them. I already imported, so chat OpenAI and give me model name as we will use latest model GPT 5 nano model. Okay. Now let me put that in chat result and let me invoke with the same question. Then only we can see what's the difference between them. So here when I just invoke, it is just giving the response. It is not giving me anything else. Now it has been done. Let's see what's there inside it. Okay, now you see it is not only giving the response, it is giving me response and some metadata as well. So that is the first difference. Okay, let me first extract the response. What is the response? So for that you need to what extract is content. So see, now it is giving in a kind of a conversation. Do this to get 4 liter in the jug. Now here it just gave me the all the steps sequentially. That's all. Okay. Now let me print what are the metadata we have. We have two metadata here. One is response metadata. So in the response metadata, you can see how many completion token you have, how many total tokens you have. Okay, this is the question token, this is the input token, output token, total token. Okay, and what are how many tokens it took to do the reasoning part, because it is doing the reasoning. Okay, these are reasoning based model. What are the exact model name we have used? I just gave it GPT-5 nano, but this is giving with the version name. Okay, so these are the latest thing. There is one more metadata also, that is probably uses metadata. Yes, so here you see exact input, output, total input token details and output token details. It is almost kind of similar thing what we are getting here. So this is with respect to the response, this is with respect to the uses. We have learned so many inferencing parameter, right? So let me change some parameter here. First parameter we can change is standard parameter has temperature. So it means low temperature will give you distinctive result. If I make the temperature high and I give you the same question, then it will give me some different results. Okay, let me just print it so we can see in the single screen. I mean, we can see it in a good way. So see, okay. So see, I mean, obviously result it will give same, but how it's giving the result, it will be different. So now it is giving the result in little more creative way. So that is what the temperature means. Now let's do the same thing for Gemini models. Let me create one more file here. Yeah. Okay, so let us so now let's see for the Gem. So here I have import all the models and I have loaded my API key as well through getpass method. And let me put another question also. This is also one kind of tricky reasoning question. Let's see how it is giving the answer. Similarly, first I will import the normal LLM, base LLM model, that is the Google Generative AI. So here you have to, so it is giving the ignore because I'm not going through GCP, I'm directly going to this. Yeah, it is showing you the answer. Now let's pass the same question to our chart models. This is that I'm using 2.5 flash light. So this is one of the latest model they have. Okay, so I got the result here. Also, if you see, you will get three things. One is content, one is response metadata, another is uses metadata. Let me print it. They are response metadata, result dot response metadata, uses metadata as well. That is kind of how much tokens you have used in the input, what is the total used, and what is the token used in the output. Now here also you have different types of parameter. Okay, here also you can pass like temperature. So first let's start with temperature. Let me put your temperature as 1. So it will give the same result but in a more creative way. Result will not be different. Okay, so there are more other parameters also. Let's try one more parameter, that is max tokens. Max tokens means it will we already discussed it. It will tell how much, what will the limit of the output response. So let me put as 200. It means it will, in the response, model response, it will keep maximum 200 tokens. Okay, let me run it with max. So you see now, when the 200 tokens completed, the response stopped. So you are getting half ended response here because I kept as 200 tokens. There is one more call as timeout. If I kept as timeout 1, it means if I am not getting the response within 1 second, then it will stop. Let me retry. See, I am not getting the response within 1 second because it will obviously take more than 1 second to get me the response. So that's why I'm uh, purposefully putting the timeout as 1 second. So up you can see it is keep retrying. Now you see it is already retry 4 number of times. So for that I can, there is one more parameter, that is, so you see, after two times retry, first time it didn't get, and second time also it tried after 2 seconds. It also didn't get. So it's telling that deadline is exceeded. So it is not able to give you the response because it requires timeout. Now there are one more good function which will allow you to run your LLM, any LLM, be it Gemini, be it Anthropic, be it OpenAI, within single function. Now here what are we are doing? We are importing separate chat models, and then we are running every chat model separately. But there is one function which will help you to run all of them in a single function. So this is the init chat model. So here, see, first I will give my provider as OpenAI, and I'm giving the model name and model provider. Let me retry first with OpenAI. See, within the same function, we can use Gemini model. Within the same function, we can use OpenAI model just by changing the model name and model provider name. So this is also one more way to access them. Okay. So now these are all about the closed source models. Now let's go to the open source models. Let me get one more notebook where we will discuss how to access open source models. So and as we discussed, there are two ways to access them. One is through the API call, another is by downloading them. I am importing two things. What I'm importing? Hugging Face endpoint. And one more thing I'm importing is Hugging Face pipeline. Hugging Face endpoint means you can access the models, open source models, via their API key. While Hugging Face pipeline means you can access them by directly downloading them. So there will be no API key required. So first we'll see how to access them by API key, then also we'll see how to access them by downloading them. Let me reload my keys. So I have reloaded my key. Now every model I am trying to put different question, and all are logical reasoning based questions, because these models claim to be at par with the reasoning part. They will do the normal Q&A part, that is fine. We'll just see how it is doing the reasoning part. So always, if you want to try from your sides, try to see with the reasoning question. Okay, so here also it will give you two things. In closed source model you are directly getting the result, but here if you see, you are not directly getting the result. What you are getting, first it is, let me scroll label it. First it is showing you think means how the model is thinking, it is showing that part. So it is telling that I have this problem, then first I need to understand this, then let me read it again. So this thinking part has been going inside the model. At the end where thinking will be end, so now the thinking has been complete. So this is our actual response. Okay. So this is the thinking part where the model is thinking how to give the result of the answer by step. Then, so in closed source model, you only get this part. But the good thing here is you are getting the thinking part also. It is not like with every model, it depends on the model, which kind of open source model you are using. But maximum models are in this format. This will only extract the thinking part. Okay, this is only extracting the thinking part, while this function will only extract the result part. So if you want to extract the result and thinking separately, because if you are displaying it to a customer, they don't care about how the model thinks, they care about the result. So you need this, so you need this function to show how the models thinks and how what the model is exactly giving the result. Okay. So this is all about accessing the open source model via API key. They also have, like here you see I have given maximum new token as 512. Here also you have those temperature, max new token. There is one more stop sequence. You have all those things. You can also apply them. Okay. But now we will also see how to you use them by downloading it. I will not do that in VS Code because my memory will get full. I will do that in, because once I'm downloading the model, right, need that much space in my system to download that model. So instead that I will do that in Google Colab, where I will have some good number of space and I can delete that space also after I used it. Okay, now we will see how to download the open source models from Hugging Face and how to integrate them with the LangChain. So for that, first I need to install all the requirement files, which I am doing here. There are few additional required libraries that is required, and I have added those all them in the requirement.txt file. So first you can see I already ran the code because it will take too much of time to download in the real time, and I purposefully used a small model. It is not a old model, but it is latest model from Microsoft, that is 5.4, but I take the mini version so that it will take less space in my memory. If you see, already my RAM is going to crash. It's already getting full almost. Out of 12 GB RAM is there, it almost getting full. So yeah, so if you see, first I have creating the Hugging Face pipeline here. So this is your where I am directly using the transformers is basically the library for that supports Hugging Face pipeline. So I am directly using that. So first I am downloading the model. If you see, it is almost a 5 plus to 7.7, almost near to 8 GB kind of model, just for I mean this is not very big. I think it is 8 or 10 billions model, and it is already coming out 7 to 8 GB, right? And it will also download many other files like its tokenizer, its JSON file, config file, its vocabulary JSONs, its add a special token map already. And if you see here, I have just given it one question: what is the capital of India? It is telling like the capital of India is New Delhi. It is located in this part, and it's also this part is directly using the Hugging Face pipeline from the LangChain library. So this is kind of a high level of, you can say it is a high level code. And here what you are shown in the first part, that is little bit low level code. Low level code means you will have more control on your code. I mean, you are creating your own tokenizer, you are I think these are little bit of topics which we will discuss in our in future when we cover the complete Hugging Face playlist. That time we'll cover this, what are these tokenizer, or what are these auto model for Kazal LM, and all these things. Okay, but here I am creating the Hugging Face pipeline using the Transformers library, but here I am directly creating the Hugging Face pipeline from the LangChain. And here if you see, the device map is equal to auto. It indicates that it will either use CPU or GPUs depending on what system you have chosen. So if you see here, I have chosen here, I will show you, I have chosen here T4 as my hosted runtime. It means it is a GPU. And if you see, it is writing that CUDA is 0. CUDA, it is 0 means it is using GPU. If it will use -1, or if it is written CPU, then it will tell you that it has been used CPU. If you see here also as well, right, I have used CUDA, and yes, it has been already ran. And you see, I am using purposefully, I'm using same model both in both the place, so that I no need to download different models every time. And if you see, it is giving here, it is directly giving you the answer. Okay, it is directly giving you the answer, because here the format of output will be different, because I am using directly the Hugging Face transformers library. But here if you see, it is giving you in the form of, I mean, how general it is give for OpenAI, how general it is give for Gemini kind of thing. Similarly, it is giving here also. And here you are getting in the inside content also. It is like it is giving you two things. One is user, what the user has been asked. What I have asked, what is the capital of US? It is given that. Then it is the end. End means it is a end token. So basically, these are the special token. This user, this assistant, these are the ends. These are the special token already being predefined with the 5.4 mini instruct model, where it will indicates that this token will indicate that user question has been started, this token will indicate that user question got end, and this token will indicate that assistance, I mean LLM response is getting started here. Okay, so you can access that using your content. If I okay, you can see I've run it again, so now it is giving me different answer. Same question, I've run it twice, so it is giving different answer. You can change your parameter as well here. Okay, here, so here you can see, this is the for the running the quantized version of your model, means the small compact version created out of that. So if it is a 1.1 billion model having, suppose let's assume 5 GB, then the compact version will be around 500 MB. It depends upon how you are doing the quantization. I am doing here 4-bit quantization. There are different types of quantization that you need to that we will cover in some separate videos detail about the quantization. But this is for your running the quantization model on the Hugging Face.
That's all for today's video in our LangChain course series, where we explored how to work with different large language models using LangChain. If you found this helpful, please like, subscribe, and turn on the bell notification so you don't miss the next episode, where we will go even deeper into LangChain's capability. Drop a comment below if you face any issues running this code or want to see specific use case. I will be happy to help you out. I will see you in the next video. Till then, keep learning, keep coding, and keep growing.